Hello everyone and welcome back to another Stormworks video. Now, with the addition of the weapons DLC coming very soon here in game, I thought it would be a great time to revisit radars here in Stormworks. Now, we have done a radar tutorial in the past, but it's been a very basic one. So I thought we'll go through and do a full tutorial on how to build a completely advanced Lua radar that can actually pick up multiple targets and also is customizable to however you want to build it. So we're going to be going from absolutely nothing to a completely fully working radar slash sonar, whichever way you want to use it. And we'll go through every single step, hopefully make it really nice and clear for you guys so that you can follow along and you can build your own radars here in game. So to get started, we're here in the workbench. Now, before we actually start building our advanced Lua radar, the first thing I want to get out the way is, of course, this is not going to be a full-on math tutorial. I'm going to show you how to build your own radar using math, of course, and also Lua. But just bear in mind that some things might not be the best solution. It's just how I've learned and how I build my radar here in Stormworks, and I will try to explain every single step and why I'm doing that step and actually give you illustrations of every single one of those steps. So the first thing we have, as you can see on my screen, is I have a radar, I have a battery, and I have a display. Okay, so I've got some very basic components that you will have to have for your own little radar. The first thing I'm going to do is I want some way to turn my little screen on. Now, for the purpose of this video, I'm just going to have it always on. Okay, so I'm just going to use a constant on block. Okay, and you can just find it over here. Place that wherever you want. I'm just going to place it next to my battery. Now I'm going to connect the electricity to my radar and to my monitor. I'm going to click my on signal over to my display. Okay? That will turn the display on and it will use some electricity. The next thing, of course, is we're going to need to create a microcontroller. The microcontroller is what's going to build and run all of this. Without a microcontroller, you will not get a radar on a screen. So let's go and do that. Now I have got some pre-built empty microcontrollers just for quicker use. You can, of course, instead go up to your microcontroller editor and do it over there. I'm going to add my empty 1x1 controller just over here, and I'm going to go and click on it. Once I've clicked on it, I'm going to click on edit, and you can see it's currently empty. So I want to start by increasing the size of it, and I also want to start by adding some nodes onto it. The first node I want is a video out. That's going to go to my display. Okay. So once I've got that on, the next thing I want to do is update that and connect my video from my actual little microcontroller over to my display. So let's start by actually doing the Lua. Now, the first thing we're going to have on my screen is going to be a circle. Simple circle on the outside, which is going to be the outside of my radar. So click on the microcontroller editor, go inside here and go into the logic. The first thing you can see is we've got our video out and we're going to add a Lua script. Grab the Lua script, place it down and connect the video out. Click on the Lua script block and click on edit. This brings up a bunch of things on our screen. Now, we don't have to use any of this, we could retype it, and you can find all these commands or functions over inside of the help panel, which is quite useful actually. So let's go over a few of these things. OnTick is something that runs every second, and it's going to go and get a number value on channel 1, and it's going to set the number on channel number 1. Now we don't need this currently, so I'm going to get rid of it. The next thing we can see is on draw. This is going to draw something to the screen. Currently I can see it's getting the screen width, screen height, it's setting the color to green, and it's drawing a filled circle at the center of the screen with a radius of 30. Now I can reuse some of this logic. Once again, up to you, but I'm going to for my tutorial. My color of green, I'm happy with that, so I'm going to leave it. The next thing is to get my circle. This is drawing a circle filled. I want a circle with no filling, just an empty outline, so I'm going to delete the F. This is drawing a circle at the center of the screen, so width divided by 2 and height divided by 2 with a radius of 30. I'm going to change that radius to 32. So that should draw a circle touching the borders of my monitor. Let's go and see if that actually works. So I'm going to check for errors, always do it, get in the habit of doing it, and click on done. I can now go and update my creation and go and spawn this in. I should now have a circle in the middle of my screen. And as you can see right there, I have a circle. It touches the edges of the display because we said that our radius is 32, okay, which is half of the screen. Great. The next thing we want is going to be a line. Okay, we want a line on our screen. So let's go and do that. And this line is what's going to eventually rotate around. So just underneath our circle, we're going to add a line. So go in, grab it. It's called function or draw line. So get that. Now draw line wants to draw between two areas. Okay, we need it to draw from the center of our screen to the outside of the circle. So the center of the screen is width divided by 2. Okay, so W divided by 2. Height divided by 2. And now we need to get the outside of the circle. Now, there's a couple different ways you can do this. I'm going to be making use of cosine and sin for this. So I'm going to say that, let's say this is x1 and y1. So x1 and y1. Okay, so we're going to go and do that. So the first one we're going to do is we're going to say that we need to find the center of our screen. So width divided by 2. Okay, we're going to add that onto the radius of our screen, which is 32. Okay, and we're now going to times that by math.cos. And in brackets is where we're going to have our angle of our radar. So 0 degrees, 60 degrees, 90 degrees, etc. We're going to do the same thing for y. We're going to do the height divided by 2 plus the radius, which is 32, times by math.sin. Okay, and that's also going to find the point. Now, for the purpose of this video right now, I'm going to set where I want it to be at 0 degrees or 0 radians. Okay, currently at the moment. You can see now we're going to draw a line from the center of our screen, which is width divided by 2 and height divided by 2. And it's going to draw it until x1 and y1. Now, x1 and y1 are already defined here, and we're getting it to radian 0. Now, before we go and spawn this in, you will notice that I've got my width and my height down here in my onDraw, which means I actually can't call it up here in my onTick unless I've gone and defined it. So half of my width is 32, so I'm just going to replace this with 32, and half my height is 32. As I said, I could move this down into my onDraw, or I could actually define my width and my height right here manually. Once again, it's up to you. So for example, I could delete this and I could go and say that my width is 64 and my height is 64, and I can now go and say width divided by 2 and height divided by 2. This is up to you if you wanted to adjust accordingly. This is quite useful to actually have it up here, because that way if you want to have this on, let's say, a 3x3 screen, I could come here and adjust this and say this is actually 96 or so on. Okay, but once again, up to you. I can also move this out of onTick and I can move it above and define it top. Okay, once again, up to you. Let's go and spawn this in. Let's go and see if we get a line across our screen. Okay, spawn it in and let's go and check. Great, we do. So we have a line from the center all the way to 0 radians. Now that's an issue. We don't want it to be on the right. We want it to start at the top. Okay, well, how do we get it at the top? Well, as I said earlier, we started at the 0 radians and we want to bring it back up the circle by 90 degrees. So 90 degrees converted into radians is going to be 1.57, 1.58. Don't quote me on that math. You guys can pull out your calculator and figure that one out. So what we're going to do is over here where we have our mass and our cos and our sin, we're going to say minus 1.58 and minus 1.58. That should bring the line back up to the top at the 12 o'clock mark. Let's go and confirm again, spawn this in, and let's go and check. So we should have a circle. Look at that. Circle with a line right at the 12 o'clock mark. Fantastic. So that is great. I'm really happy with that so far. So the next thing, of course, we want to do is we want to get that line to rotate around our screen. There's a couple different ways you can do this. In my previous Lua radar tutorial, which I think we did about 1.5 years or 2 years ago, I used I think a pivot that was constantly rotating around. Now there is a better way to do it, and you can actually do it in here using some math. So we're going to start off by saying that the angle in which the radar starts at is, let's say, 0. Okay, so I'm just defining that at the top of my screen right now. I'm also going to define my speed of my radar. So let's use 0.004 or 3. I don't know. You guys can play around with this. And in a later video, I'll show you guys how you can adjust some of these things. So it can be completely customizable and you can change it on the fly, the speed, you can maybe change the size, the range, etc. Okay, so we're just going and putting these two things in now. So telling it where to start at and what our speed is. The next thing I'm going to actually go and do is I'm going to go and tell the system, hey, you know what? Our new angle is going to be our angle plus our speed. Okay, so it's going to take 0 and it's going to add 0.3. And as it adds that, it's going to carry on adding it and adding it and adding it. And that's how we're going to get a rotation around. Okay, because this gets called every second. So every second it's adding 0.0003. That's fine. Now our radar and also our little screen here works in a couple different ways. Okay, currently on our screen here we have radians. Okay, and we also on our radar we're going to have a value from 0 or negative 0.5 all the way to 0.5. Okay, we want this all to rotate and stuff. Okay, now this angle here, okay, which currently at the moment is going to be set as 0 and it's going to add 0.03. Okay, we want that to reset. Okay, every single time it reaches a value. Otherwise, it's just going to keep on going and going and going. We want it to reset. So we're going to say that if the angle here, okay, so if angle is either greater or equal to 0.5, then we're going to reset it. Okay, so we're going to put then, we're going to say now a equals negative 0.5. Okay, and we're going to end that. So that's a simple way of just resetting it. So it starts by adding it, adding it, adding it, adding it, and then it starts by resetting it, resetting it, resetting it. Okay, and it just keeps on looping this and looping this and looping this and looping this. Okay. Now, the next thing we're going to do is we, of course, want to go and send this A out. And that's what's going to tell our radar to go and rotate. So we can go and use an output. So we can go and grab a simple out number, and we're going to send it out on channel 1. Yeah, so channel 1. Oop. And we're going to say A can go out, please. Yeah, there we go. But we want to actually get our line to move, which is over here. Okay, we want this line to rotate around our screen. So how the heck are we going to do that? Well, we need to go and take this value over here, or A in theory, which is currently negative 0.5 all the way to 0.5, and we need to convert that into radians. How do we do that? Well, let's go and do a little bit of math. So we're going to say that, let's say our radar A is going to be equal to, let's start off with A, which is currently our angle. So that it could be negative 0.5, it could be 0.5. And we need to convert that into a 0 to 1, a whole number. So to do that, all I have to do is add 0.5 to it. Okay, so that's converting it to a whole number. So 0 to 1. We now need to go and convert that into degrees. So I'm going to go and put it by degrees. So 360, for example. Okay, just over here. Put in brackets once again. The next thing I want to do is convert the degrees into radians, because that's what I use for my plotting of my circle and my points on my circle. So to do that, I'm going to do what I've got at the moment, and I'm going to times it by math.pi divided by 180. And that will give me my radians. So now I can take this radar A and plus it to whatever I had on my circle earlier. So as it rotates, it should rotate my line on my screen. Remember, I've also got this angle that's coming out and going to my radar. I can update this. I can also add an output for my radar now. So I can go and add a new node. This is going to be radar yaw. And it's going to be a number out. Make sure I've got that connected, but hold on, I can't connect this composite over into a number. So how do we do that? Well, you can use a write, okay, or a read. So I can go and read a number from composite, and I'm going to read it on channel 1, and then I'm going to send it out. Update this now. I can get this connected to my radar if I wanted to. on my yaw. You don't have to do that now because there's actually no way of knowing what the way it's facing, but we can have a look at it in a few seconds. So now if we go and spawn it in, we should see a line that rotates on our screen. And it does, but hold on. It started down here at the bottom. We wanted it to start all the way at the top. Now we did tell it that it originally started here to go back up there, but now it's actually starting down here. So why is it doing that? Okay, and you'll notice that if we go to this radar and have a look at it, it's at 0.045, which should actually be, yeah, at the bottom. Okay, but it's not. It's actually all the way over there. So we need some way of bringing this back up. I also like that it is resetting itself. As you can see, where it was in positive, now into negative. Okay, so we need some way of either bringing it back a little bit or pushing it up a little bit. Okay, because at the moment, it's not really doing what I want it to do. So we can do a few different things. The easiest way here would be to go back into our Lua script, and instead of doing a negative 0.58 or 1.58, we're just going to make it a positive. Check that again. Spawn in. We should now have our line that starts right at the top. Let's go and check. Aha, there we go. So now it starts at the top, and then it's going to start rotating around. Okay, let's go and check it. There we go. That looks much better. But this is going quite slow. How do I make it go quicker? Well, back into the microcontroller edit again, and remember that value I used for speed earlier? Well, I can change it. I can remove a 0, for example. Okay, let's go and check it now. It should be running much quicker in comparison to what it was a few seconds ago. Aha, that looks better, doesn't it? Reset, boop, go again, reset, boop, go again, reset, go. Fantastic. Great. So now onto the last part probably for this video. How do we get the targets on our screen? And not just one target, multiple targets. So there's a couple of different ways you can do this. The first thing we want to do is we want to go onto our controller and tell it that we're reading two things from the radar. Reading if it's found a target or detected one, and what distance that target is at. So I'm going to go into design, I'm going to add two nodes. One node is going to be for the target, and one node is going to be for the distance. Cool. Distance is a number in, and the target is an on-off in. We can update that and make sure we connect the logic for it. So go and connect it, target found, to our radar, and the distance over to our radar. Okay, so we've got that. Now we can go and do some more Lua magic and some maths. So we're going to go into the logic, and you can see here we've got our distance and we've got our target. Now we need to get those two numbers into composite. How do we do that? Well, once again, with a composite right. Okay, so we're going to get composite right number and a composite right on off. We're going to take the number into our composite right, on off, into our composite right, and we can see we've got two composite outs, but only one in here. So we're going to take the bottom one or the top one, go into that one, so it's a pass through, and then it's going to go through. Now both of these are on channel 1. That is fine. There are two different types of nodes. One is a number node and one is an on-off node. You can override them or overlap them. Now we can actually go into our Lua script and we can edit the Lua script. The first thing we want to do is read those two things. So inside of my function onTick, I'm going to add getBool and getNumber. We're going to say that the bool is the target, so target, and the number is our distance. And we're reading it on both channel 1 and channel 1. Another thing that we can define now, and this is something we'll do in a later video where we'll go and add a feature on to scale the max distance. We're going to tell the system that our maximum distance that we want our radar to operate today in this video is going to be 100 meters. Okay, you can change this to whatever you want, and I'll show you how to scale this at a later time, but right now we're going to say it is 100. So, what do we do next? Well, the next thing we need to do is we need to go and find the point of that target on our screen. Now, it works very similar to finding the point of the line. Exactly the same process. We can just copy and paste this whole part, exactly the same. Let's say this is x2 and y2. Only difference is instead of using the radius of the screen to find that point, we want to use the distance, yeah, that we're finding it. Okay, so we want to use the distance. However, that doesn't regulate to on-screen pixels. Distance, let's say 1,000 meters, is not 1,000 pixels. So we need some way of converting this distance into pixels. And to do that, we're going to say that our, let's say, distance pixel is equal to distance divided by the max distance. Okay, so that will give us, let's say it's 20 meters out of 100 meters, that will be 0.2. We now need to convert that into pixels. Well, what's the radius of our screen? 32. So we're going to times it by 32. We're just going to put it in brackets so it works out the dividing first and then times it by 32. Okay. So now we've got the location on our screen where we can draw that. So I'm going to replace my 32 with my distance pixel. So that should give me a location on my screen on where I need to have a dot, for example. Okay. Now, we could go and carry on and just tell the system to draw a dot at x2 and y2. Only problem is it's only going to ever draw one. And this is where we're going to use some Lua magic. Or when I mean magic, some Lua functions. And this is going to be tables. So we're going to use a table to store these points. Every single time the system detects a target, it's going to store the points of the target in the radar or in a table. Then it can actually show all those targets in one full rotation. Then it will reset it every time. And I'm going to show you guys how to do that right now. So the first thing that we're going to need to do is we're going to need to define that we have a table. So we can come up to the top and let's do TRT targets. And we're going to say targets is equal, and we're going to tell the system to open a table. Okay, there we go. So that's our table that we're opening to start with. The next thing we need to do is we need to tell the system to store x2 and y2 every single time it reads that there is a target. So if target, then add to this table. Okay, and we're going to add our x2 and y2. Okay, so we can go and write the code that we need. So we're going to start by entering in our table. So we can just grab this, paste it in here. Targets equal, open brackets here. And we're going to say that, well, tables, how they work is they have an index and a value. Okay, so we're going to say that the index, okay, so let's go over here. We're going to say that is going to be x2 and the value is going to be y2. Okay, so pretty too. So let's go here, and so that's y2. Okay, so index is x2 and value is y2. Okay, and end. So what that does now is every single time it detects there's a target, it's going to store its location on the map. Now, what we can go and do is we can go and tell the system to go and draw all of those things on the map. So we're going to say that for, let's say, let's use x3 and y3. Okay, so x3 and y3. And we're going to say 4. So for every x3 and y3 in pairs, okay, which pairs is this for it to rotate over the table. And what table are we doing it on? We're doing it on this table over here. So now it's what this is doing. It's reading that table. It's going over every single value in that table. And once it does that, it's going to go over and it's going to go and draw a color. First thing I'm going to do, I'm actually going to set the screen color to red. That way you can draw a red circle. And let's just do 200 by 0 by 0, and let's draw a circle. So if I go in here, grab draw circle, I'm going to do circle filled this time. Grab it there, put it over there, and the radius, let's say 2. But where are we drawing it at? Oh, well, we're drawing it at x3 and y3. Okay, and then we can end this. So guys, just a quick recap on that. Every time the system detects there's a target, it detects what the x and the y values are for that target. It stores it in a table with a index of the x and the value of y. Then in our onDraw function, we're telling it to go over that entire table and find the value and the index. I could literally go over here and call this I and V, and then go over here and call this I and V. It doesn't matter what you call this, okay? In our example, it knows that this is the index and this is the value. And then every single time it detects something, it's going to draw it on the screen here. So it's just using tables, guys. And tables makes the Lua so much more powerful. Let's go and check to see if this is going to work. So double check all this. It looks good. Update it in here. Make sure I've got my logic, targets and distance. Yes, I do. Electricity. Yes, we do. Update this in and let's go and check. And there we go. Doop, detecting every single one of those targets within its distance. Now, this is just going to keep on adding and adding and adding. And as you can see, if I was to move around, let's say if I was to move here at the front, it's going to keep on adding more and more targets on, okay? Which is not what we want. We want it to reset every single time it does a full rotation. So 360 degrees or 6 point something something radians. Okay, so we need it to reset. Well, how do we do that? Well, we can go back inside here and we can tell the system to empty that table every single time it's gone through a full rotation. Well, how does it know that we've done a full rotation? Well, we can go and simply go and get it from here. If this goes to, I think 0 or positive 0.5 or whatever it is, that means a full rotation. Okay, so what we're going to go and do now is we're going to say that if this, which is the rotation, if the radar A is equal to, let's say, I don't know, 0, or you could do 0.5, that's a full rotation, then, or you could do actually negative 0.5, that could be a good one, negative 0.5, then we want you to go and delete all the values from our table. Well, what's our table? Well, we need to go and tell that to go and do it, just like we did to go and tell it that every single time it finds a target, I want you to add to the table. Okay, so what we want to do now is we're going to go and tell the system that for every I in the table, which is pairs targets, do, and we're going to now say that targets, so just like we did earlier to read this, yeah, just over here, we're going to now say I is equal to nil, which is nothing, okay, empty, and we're going to end that, okay, just like that. So now what's happening is it's checking to see if we've done a full rotation, and it's going and overwriting what we have on our targets, and it's not just doing it for one, it's doing it for every single one. Remember, pairs goes and reads over every single value in the table. So for every single value in the table, it's making it I nil, okay, and that's how we're getting our reset. So let's go and check that again. There's a function error at 9, so let's just go and double check that, where that is. I think I forgot to put an end. Yes, I did. Okay, so at the end, that's why you always check the errors, guys, before you do anything. Double check that in, update it, spawn it in, and let's go and check. There we go. It's detecting all its parts. When it gets to the top, it should reset. Okay, so it's not resetting. Now, there can be a couple of reasons why this is not happening. The most likely reason why this is not happening, and the reason why I'm talking about this, because it might happen to you, is that one, it's going too fast, the speed is going too fast, and it's never actually getting to negative 0.5. It might be getting to 0.49999, okay? So, there's a couple different ways you could do this. You could say that if this is less than this value, or if it's more than this value, or you could just do 0, because more than likely it will obviously go over 0, okay? You could do plus 0.49 greater than, etc. It's once again up to you, but equals 0 usually will usually work. Let's go and just double check that to make sure this is going to work. Update that in again, and now let's go and see. There we go. It went and reset. It's going and finding all of its targets, going across, reset. Carry on going, and you can change that number depending on when you want it to reset. And now you can see it's going across, going to us. You can change the radius of these circles if you want them to be smaller dots. As I said earlier, I set it to, I think, a radius of 2. You can go back into the Lua script and change that to a radius of like 1. That way it will make smaller dots on your screen. Okay, so let's go and check. There we go. Nice smaller dots. That's me. That's that. That's, I think that. That's this stuff, etc. Which is pretty cool, isn't it? So you can play around with this. As I said, I'm going to do another Fallout video on this, guys, where we're going to add some shadowing onto this line. I'm going to add some settings to turn this radar on and off. I'm going to add some settings to increase the distance, decrease the distance, change the colors, all the things. I'm going to add so many more settings onto this. Definitely keep out for part number 2. Now guys, I really hope you have enjoyed this video. Obviously it does take quite a lot to obviously get everything all lined up here for you guys and obviously explain all these things. So I hope you have enjoyed it. If you have, smash the like button, hit the subscribe button, and of course keep an eye out for part 2 where I show you guys how to add some more features. And until then, we will see you soon.